Hi, I'm George and welcome to part 5 of the Tajfun series. In this episode we're going to have a look at the parachute deployment mechanism. Now, we don't have the luxury of motor ejection charges like we do with Pyro rockets, so this one's based on the bungee method that we've used in other rockets, but it has a couple of small improvements. So let's go have a look at it. The parachute deployment mechanism sits right here on top of the pressure chamber. We'll first start off by printing the main component. For want of a better name, I'm calling this thing the cup. This holds all the other components together. Next, we need to make the parachute ejection bracket. The lower part of the bracket's made from a small carbon fiber tube. This will be held in place by a couple of carbon fiber flat sections. The carbon fiber is needed here for its stiffness, as there'll be a lot of force put on these. Here we're just rounding off the edges. These flat sections then get epoxied into the bottom of the cup. We made sure there were vent holes in these slots so that it wouldn't build up pressure when we push them in. We then used a couple of countersunk screws as pins to hold the tube between the two flat sections. Now, this bracket is sized large enough to easily hold the parachute between it and the cup and still be fairly loose. We then let this thing cure overnight. Next up, we 3D printed a pair of levers and a bracket to hold them. The levers just pivot on pins made from steel wire. Now, these levers will hold the entire mechanism closed. The levers then get mounted inside the cup. Here you can see where the levers emerge on opposite sides of the cup. Next, we printed the servo motor and electronics brackets. This one holds the timer and an altimeter, and also our power switches here. They need to be elevated like this so they are accessible above the cup so we can then turn things on. This subassembly then fits over the lever bracket and gets screwed to the cup. Next up, we have to make some holes in the payload bay tube. We made this tube back in the first episode, so if you want to see how that was made, just click up in the top right corner. We need to make a couple of square holes in the walls where the levers are going to emerge. Now, you have to do this very carefully because you want there to be as little give as possible. We're just using a square file to increase the size of the holes until we have a good fit. We then want to mount the other end of the tube on top of the pressure chamber. Because the PVC ring on the pressure chamber already has mounting holes drilled into it, we need to transfer the hole locations to the tube. The easiest way to do that is just to shine a light down the tube, and then we can mark out the centers of the holes. And the screw holes then can be drilled out. After the payload bay tube is painted, we can attach the rubber bands. This is the easiest way we've found for attaching the rubber bands to be able to take the load, but have minimum protrusions on the inside as well as on the outside of the tube. All the rubber bands are just held down with this one single wire. The number of rubber bands and their length is chosen to give you the right amount of kick. This is how the frame and cup is loaded into the tube. But now we don't stretch the rubber bands like we used to when we do this, so it makes this step much easier. Later, we'll see how the rubber bands get stretched and hooked onto the frame. You put the cup in and rotate it until the levers pop out through the square holes. Here is a view of the levers unlocked, and they are free to move. When we want to lock them in place, we just turn on the servo timer and the servo horn moves over the top of the levers to lock them in place. To release the levers to deploy the parachute, the servo horn just needs to move out of the way again. Here is a close-up of the servo horn and the levers being locked and unlocked by the servo. Now we can attach the nose cone to the cup. The nose cone is just attached with 6 M3 screws. We then add a short string between the bracket and the shock cord. This is what's going to prevent us losing the whole nose cone. We could have tied a knot in the main shock cord around the frame, but this way it allows the shock cord to remain fully straight during maximum loading, as knots can reduce the strength of the cord significantly. The other thing you will notice here are the big holes at the bottom. These help with the ejection by letting air in behind the cup as it's ejected, otherwise it creates a vacuum behind it. It's the opposite of what you would need for black powder ejection charges, where you pressurize the tube. Okay, time to do some testing. First we need to load the parachute into the frame and then insert it into the payload bay tube. The parachute is quite loose in the frame, so it will fall out easily. The cup then gets locked into position. We then use a hook made from a coat hanger to stretch the rubber bands onto the frame. This is a lot easier to do than trying to force the entire cup into the tube while stretching the rubber bands like we used to do. Once the rubber bands are stretched, we can gather up the shock cord and push it into the base of the payload bay tube. And the tube can then be mounted on top of the pressure chamber. And finally, the nose cone gets fitted. Okay, so let's test the ejection. Here we're just using a timer to activate the servo. Here are a couple of tests from different angles. These first tests use 4 rubber bands and a couple of weaker ones, so essentially 5 rubber bands. In later tests we increased this to 8, and that gave us significantly more force. We'll see that in a future video. So that's the parachute deployment mechanism. I hope you found it interesting. In the next episode, we're going to go have a look at finishing off the rocket. We're going to attach the fins. We're going to attach a couple of other small things, paint it, and ultimately also do a pressure test. So anyway, thanks for watching, and we'll see you next time.